Okay, coming to you in the middle of a hurricane. Okay, it's not really a hurricane anymore. It's already gone down to a depression and I got power back so I could do all this. But don't know if the power is going to stay. So I could end up in like 10 different outfits for this one video, but that's okay. I can make things happen. Sure, it'll happen that way. Today we're actually going to talk about corresponding triangles and parts of corresponding triangles. I'm using the idea of similar triangles to talk about corresponding parts, and then we'll talk about congruent triangles, which is technically what the section is about, and then eventually we'll get back to similar triangles and what that really means. But for the moment, that is the symbol for similar. It's like the very top of the congruent sign. Just that says that they are similar. So this statement says the triangle ABC is similar to triangle DEF, which tells me a couple of things, but it more importantly allows me to take care of some information like what corresponding parts are. So let's get a nice color. Pink. I'm wearing pink. I'll use pink. So it's underlined because I need you to understand what corresponding parts are. And I forewent the whole highlighting video for this section. Wasn't that kind of me? Because the only thing in this section for you to highlight was the definition for congruent triangles, which I'm going to write down later anyway. So for corresponding parts, you can have a whole host of different corresponding parts for triangles. We talked some about corresponding parts because I called them corresponding when we were doing the parallel lines. So we had some corresponding parts there where this corresponds to that and this corresponds to that because it was in the same general area, just at a different intersection. So it's the same kind of idea, only now we have to be a bit more specific. And we have to get a bit more specific because we have to be a bit more exact about what we're talking about and what we're leaning towards and how we're getting along with stuff. So, angle A is the same as angle D. Now, I know it looks like it's different, but since they called them similar, I know that that has to be the same. We'll get more into that in a second. But just for the list of corresponding parts, we have angle A corresponds to angle D, and that means that angle B corresponds to angle E, and angle C, I can make it a C. It can happen. Corresponds to angle F. That took care of my angles, but we also have to take care of the sides. So we can say that side AB corresponds to side DE. Make sure you put the line over it, because if the line isn't over it, that means we're talking about distance. And then side BC corresponds to side EF. And then side CA corresponds to side FB. Which brings us to a conversation that we really need to talk about. And I'm going to use this up here to help me explain that conversation. I told you in a prior video that sides were opposite angles and angles were opposite sides. You had to be kind of specific about that kind of stuff. And it's true, you do. But in addition to that, there's when we talk about triangles, it doesn't matter if we're talking about congruent triangles or similar triangles, there's a pattern to them, and you have to maintain the pattern because the pattern tells you some rules. So here, A, we said corresponded to D. We said B corresponds to E, and C corresponds to F. And that always happens. It always goes in order like that. That's how I knew that these angles were the ones that corresponded. Not because it looked like it, because you can't go off of looks. I had to have a statement up here to tell me. So we kind of said it's general, but you know, it's Joanna's drawing it, so it might not be exact, and that's okay, because she gave us the real thing to go off of. So since I went off of that for this, I also had to go off of this for this. So when I said AB, that was my first line here, which linked these two. So it had to correspond to my first line here, which linked those two. And it has to be given in that order. If I'm going to talk about BC, then that means that I'm also talking about EF, and they have to be given in that order. If we're going to call angle B before angle C, I can't turn over here and say angle F before angle E. That's the wrong order. You've got to become more exact about that, even though it's talking about the exact same segment, and we know that. It's the wrong order. That is the reflexive property at work. It's because of the reflexive property, we in our heads know that BC is the same thing as CB. So we just jump to it. But for exactness sake and for geometry's sake and for proof sake, we can't. We have to use the reflexive property to turn them around so that they match what they're supposed to match. Same thing works with angles when you're talking about, if I listed, instead of just calling it angle A, if I listed angle CAB, and I wanted to call it congruent to an angle, the angle I would have to choose would have to be angle FDE, because I have to call them out in the exact same order of corresponding parts. So I can't call it congruent to angle EDF. I would have to put that extra step in there saying the angle EDF is congruent to angle FDE by the reflexive property, because it's the same thing. And therefore, we can say that angle FDE is congruent to angle CAB. So you have to be careful about what order things go in. You can't just throw them out, even though we know what it is because we have eyes and we can see. You can't say that in a proof. In a proof, you have to be much more exact. So make sure you use the reflexive property when you need to make things go in the order that they need them to. Okay, there's that small conversation done, which brings us to a conversation about congruent triangles. Definition, I guess it's spelled that way. Definition of congruent triangles. That's not the symbol for congruent. Ooh, definition of congruent triangle. Says the corresponding parts of congruent triangles are congruent. And this is the part right here that we'll use for our reason whenever we need a reason. Oh, lovely. Huh. Sorry. Just noticed something. I have to get to that later. Okay. So the definition of congruent triangles says the corresponding parts of congruent triangles are congruent. That's how we knew that the triangle that I had drawn was not a congruent triangle, because it had much longer sides, so they couldn't have been congruent. If I wanted to draw a congruent triangle to this one, it would have to be something like, oh, give me a second. We can dream. I'll call this F, G, and H. Just so when we start listing off stuff, then we'll be able to tell. And if I wanted to list these as congruent, can you tell which angle corresponds to which? So if I told you that these two were congruent, then that would mean that angle A would have to be congruent to angle F. And if I told you that angle B is congruent to angle G, doesn't look like it, but we'll say it is. And angle C is congruent to angle H. You notice how when I got a different size angle, I changed the number of tick marks inside? That's how you know them apart. So if I have that, then I also have to talk about the lines in between them. So that would mean that FH is congruent to AC, because if I'm starting at the angle that has no line and I go to the angle that has two lines, over here I have to start at the one that has no line and go to the one that has two lines. That's how I knew it was AC. If I'm talking about side HG, that would have to be congruent to side CB. And if I'm talking about side GF, that has to be congruent to side BA. So we just said that this one was congruent to that one, and that this one was congruent to that one, and that this one was congruent to that one. Not necessarily in that order, but that's what we said. When you have congruent triangles, you really need to get in the habit of going ahead and marking every side that's congruent to every side and every angle that's congruent to every angle, so that you don't get mixed up later on. Always mark your pictures as much as you can. Now, in order to have congruent triangles, as you can see, they don't have to be side by side. They can be twisted and turned any way you want. Don't have to be connecting, don't have to share a side, don't have to be anywhere near each other to be congruent. but they do have to have corresponding angles and corresponding sides, and those corresponding angles and sides must be congruent. Okay. Took care of that. So now I'm supposed to give you one to try. It won't be much. Surely not. I wouldn't do that to you. Not at all. Just gonna do a little bit of drawing. Given these four triangles, there, triangle ABC is congruent to triangle blank. Triangle DEF is congruent to triangle blank. Okay, they're not really drawn to scale, but they're close. Really close. Okay, I'll doctor it and make it a little bit closer. That looks better. And then triangle ABC, big old blank there, to triangle DFE. So this should be DEF. Hold on. I changed my stuff up here. And then one more. Side AB is congruent to what side? Okay, pause it for a second. Go ahead and do those four. Let's see how you do. Okay, let's fill them in. Triangle ABC. Here's my A, here's my B, and there's my C. Now it's true, in none of these did I mark the other side. I didn't mark the other side because I know that triangles all have to add up to 180, and if these two are the same, then that one's going to have to be the same. So I really didn't need to mark the other side for it to be a true fact. So back to what I was saying. Triangle ABC is congruent to, is it going to be one of those two or that one? Well, it must be this one because it's a big triangle with a big triangle. So if it's going to be congruent, we have to have big with big. And if it's going to be congruent, angles have to be lined up. So where my A is corresponds to where my L is. So that has to be my first letter. And then my B corresponds to where my K is. And my C corresponds to where my J is. So it's triangle LKJ. It's a J, I promise. I got a little curvy with it, but it's a J. Triangle DEF is congruent to triangle HGI. Ooh, I put 2 F's. You should have said something. And then triangle ABC and triangle DEF, do they look like they're the same size? No, but they do have corresponding angles. That makes them similar, not congruent. And then side AB is congruent to which side? Well, AB is the side that's across from C. And we said C is the same as J, so the side across from J that starts at L and ends at K would have to be LK. If you got it from the pictures, that's great. If you got it from up here, that's fine too. Doesn't matter which one. Okay, so that is the end of section 4.1 for you. Hey, look, all in one video. That was pretty good, right? But there is classwork and there is homework. So, classwork on page 131 in the practice exercises, numbers 7, 11, 13, 15, and 17. All those answers are in the back of the book, as are your homework. Numbers 9, 19, 23, 25, 27, and 29. So I got a little carried away with the homework. You'll be okay. I think you can do it all. I will see you, well, you will see me tomorrow. Bye.